Roadbond EN1 is a patented soil stabilizer developed by CSS Technology Incorporated in 1986. It is easy to use, cost-effective, and environmentally harmless, and that is a direct quote from the U.S. Forest Service. Roadbond EN1 is a highly effective, proven soil stabilizer that tackles the important challenges related to the construction of drilling locations and lease roads. These challenges are to reduce the consumption of water and natural resources, conserve base material, lower maintenance cost, and to reduce the construction impact on local roads. Also, it is vital to offset energy consumption, to lower greenhouse gas emissions, and to minimize the carbon footprint of drilling locations and lease roads. Roadbond EN1 offers three primary benefits. It is used to stabilize clay subgrade soils, enhance Portland cement and flyash, and to improve the strength of crushed stone base material. When applied to clay subgrade soils, it will significantly increase the strength, reduce the permeability, and increase the dry weight of the clay soil. It produces a working table for construction in wet weather and creates a solid foundation on which to place the base material. Lime is often used to stabilize clay soils. One disadvantage of lime compared to Roadbond EN1 is higher cost. Besides, lime must be remixed after 72 hours for maximum performance. However, Roadbond EN1 is placed, mixed, and compacted in one day without the need to remix. Also, lime will increase the permeability and lower the dry weight of clay soil, which allows more water to migrate into the stabilized subgrade and produces less mass underneath the base course. This creates a potential for soft spots to form and maintenance costs to be incurred. In addition, lime has a very large carbon footprint. It is manufactured by the calcination of limestone rock in a kiln furnace, and more than 7 tons of limestone must be mined to produce 1 ton of lime. According to published information, the production of just 1 ton of lime will release over 1.3 tons of greenhouse gas and heavy metal pollutants into the air, and consume the equivalent of 2,000 kilowatt-hours of energy. This is enough energy to power the average U.S. home for over 2 months. Given an example drilling location of 300 feet by 450 feet, using Roadbond EN1 instead of lime will offset over 420 tons of greenhouse gas and heavy metal pollutants released into the air, and conserve the equivalent of 840,000 kilowatt-hours of energy. That's enough energy to power more than 70 homes for a year, and that's just one location. Additionally, the truck traffic that is generated in order to deliver the lime to the location is eliminated, and that reduces the damage and maintenance to the local road network. Over time, this can lessen the production cost in the area. Those projects that require Portland cement for soil stabilization can benefit from using Roadbond EN1 as well. Many lab tests and field trials have determined that Portland cement can be reduced by 40 to 50% when Roadbond EN1 is added to the design mix. This will save money, installation time, and reduce the Portland cement-related truck traffic to and from the location. Also, because Portland cement is produced by mining and calcination in a similar process to lime, significant environmental benefits are achieved. Roadbond EN1 is also used to improve the strength and lower the permeability of crushed stone base material. This may permit lower quality local base material or salvage base to be used for many projects. It is also possible to reduce the overall quantity of prime base material. This will cut costs and minimize the impact of rock trucks on the roads in the area. Another gain is that the damage to the location that occurs during the drilling phase is significantly reduced. As a result, maintenance and rework to the site before fracking and completion can proceed is notably reduced or eliminated completely. Testing entities that have evaluated Roadbond EN1 include the Texas DOT, the Oklahoma DOT, Caltrans, the Department of Transport, South Australia, the Texas Transportation Institute, and the U.S. Forest Service. Also, many private geotechnical and construction materials testing labs have tested Roadbond EN1. These tests include unconfined compressive strength, falling weight deflectometer, Texas triaxial strength test, Dynacone penetrometer, and other accepted methods in order to quantify the improvements that take place in the treated soil. Specifically, the Texas Transportation Institute reported that Roadbond EN1 is superior to lime in terms of strength, stiffness, permeability, and swell resistance potential. Furthermore, tests performed by the Texas DOT showed a strength increase of more than 200% when Roadbond EN1 was added to a combination of limestone base and 4% fly ash. When the same base material was tested with Roadbond EN1 without the fly ash, the strength increase was also over 200%. Field evaluations were conducted in the Eagle Ford Formation south of San Antonio, Texas. One location was stabilized as usual, with 14 loads of Portland cement, while a neighboring location was stabilized with only 7 loads of Portland cement and Roadbond EN1. This saved 21% of the cost of the stabilization materials and offset over 225 tons of greenhouse gas. Both locations were tested for strength 14 days after construction and then again about 45 days after construction. The location with 14 loads of Portland cement had an average CBR of 63.9. The location with 7 loads of Portland cement plus Roadbond EN1 had an average CBR of 84.9. That is a strength increase of 33%. Over the next 2 months, 9 more locations were tested. Once more, one of these locations was stabilized with 14 loads of Portland cement and no Roadbond EN1. The CBR of that location was 62.5. The other 8 locations were stabilized with Roadbond EN1 and only 6 loads of Portland cement, which is 57% less Portland cement. The CBR of these locations averaged 75.9 for an increase in strength of 21%. In the Barnett Shale near Fort Worth, Texas, Roadbond EN1 has been used extensively in both the subgrade and in the base course. For example, after a soaking rain, the improvement in the treated base material compared to the untreated section is dramatic. More evidence is seen on the Lease road that leads to the location. Drilling traffic has barely marred the road, whereas the untreated main Lease road is sloppy and tracking badly. Even though this location is wet from rainfall, there are no soft spots or failures and the drilling rig is moved off without delay. No maintenance was required before the fracking crew moved on to the location. Roadbond EN1 will also reduce soil erosion associated with heavy rain. Floodwater flowed across the stabilized base material with very little washout. This will conserve base material and reduce maintenance. A typical location and Lease road is firm and dry after months of traffic and will require less maintenance over time. In the Woodford Shale in Oklahoma, XTO Energy has adopted the use of Roadbond EN1 on its drilling locations and Lease roads. Lime stabilization has been eliminated completely, and the use of Portland cement has been dramatically reduced. This method saves construction time, reduces truck traffic to and from the location, and has lowered the total cost of the stabilization by over 50%. Also, the creation of over 580 tons of CO2 and heavy metal pollutants are canceled on each location, and energy consumption is offset by the equivalent of 1.1 million kilowatt hours. That is enough energy to power more than 95 homes for a year. Roadbond EN1 is also used in the Bakken Formation in North Dakota. For example, this location was stabilized 12 inches deep with Roadbond EN1. Stabilization of the subgrade permitted the geofabric liner to be eliminated completely and the base rock to be reduced substantially. This represents a significant savings, shorter construction time, fewer rock trucks in the area, and less impact on the environment. The use of Roadbond EN1 to replace or reduce conventional stabilization is a comprehensive strategy that demonstrates quantifiable environmental benefits, cost savings, and performance. It promotes a sustainable environment in the areas that matter most: energy savings, reduced water usage, reduced CO2 emission, and stewardship of resources. It has withstood the test of time, changed the status quo, and redefined stabilization. For a greener today and a cleaner tomorrow, specify Roadbond EN1 patented soil stabilizer on your next project.